Write the polar equation of a conic section using integer coefficients with a focus at the origin or pole and eccentricity equal to 1/3 and a directrix of y equals -4. Whenever we have an ellipse, parabola, or hyperbola with a focus at the pole or origin, then we can write the polar equation of the conic in one of the forms above. Because we are given a directrix of y equals -4, which is the horizontal line, we'll be using the second form where the equation involves sine theta. If we were given a vertical directrix in the form of x equals plus or minus d, we'd use this form here on the left involving cosine theta. So let's write down the form of the equation we'll be using, which again is r equals e times d divided by the quantity 1 plus or minus e sine theta. And now let's record the given information. We know the eccentricity equals 1/3, and we know a directrix is the horizontal line y equals -4. This indicates we substitute 1/3 for e, and then because the directrix is y equals -4, because of the negative, we will use the minus in the denominator. If we go back to our notes, notice if we had y equals +4, we would use the plus in the denominator. And then finally, the value of d is 4, and therefore we substitute 4 for d. Let's perform the substitutions. We have r equals e times d is 1/3 times 4 divided by the quantity 1 minus 1/3 sine theta. So while this is the correct equation, we want integer coefficients, not fractions. So let's first write this as 4/3 divided by the difference of 1 and 1/3 sine theta. To clear the fractions from the equation, we'll multiply the numerator and denominator by the denominator of 3. This is equivalent to multiplying by 3 divided by 3, which equals 1. We're just changing the form. Our final form is r equals 3 times 4/3 equal to 4. In the denominator, we distribute 3, which gives us 3 minus 3 times 1/3 sine theta is just minus sine theta. This is the polar equation we are looking for, which because the eccentricity equals 1/3, which is between 0 and 1, would be an ellipse. I hope you found this helpful.